This is a video to introduce the apparatus and the use of a digital multimeter for Lab 4, Physics 1051. In this experiment, you'll have a couple of electrical leads. Many of our leads, the two ends will be different. So here, two of our ends are the banana clip, the banana leads. They're the ones that plug directly into the ports. The other two ends, if you look closely, you'll see that those are alligator clips. We'll be using those to clip onto the components of our experiment. We're going to use our DC power supply. When we use this, the part we're going to use in particular is the constant 5-volt setting. We'll connect that using the two tabs underneath the symbol for our 5 volts here. We've also got some small jumper cables. We'll be using that with our breadboard to connect our circuit. The breadboard is an interesting device. The top is plastic with a set of holes. Underneath the holes are strips of wire. Along the top 2 rows and the bottom 2 rows, the strips of wire are horizontal. What that means is if you connect anything along a horizontal row, here, or along the bottom 2, those will all be connected. In the middle, these are different. These are connected by vertical strips, so anything in a vertical row would be connected. That'll be important when we make our circuits later on. Let's see, we also have a set of resistors. So we have 4 resistors. You may notice that your resistors will all have different colors. The colors tell us the approximate values of the resistances. You'll have a slide in your instructions showing you the color and telling you the associated resistance. You might want to keep that handy. And then we have our digital multimeter. We use digital multimeters to measure either voltage, current, or resistance. So we choose the setting depending on what it is we want to measure. One thing really important about using your multimeter is that you don't ever turn it on. We don't turn the dial while the circuit is completely connected. So we only switch this dial and then we complete the connection. All right, so the first thing we're going to use our multimeter to measure is going to be the resistance of our 4 resistors. So we'll take our resistor R1. R1 has the color stripes of gray, red, black, and gold. We'll connect our resistor to our electrical leads using the alligator clips. So we'll just open it up and then clamp it on. Try and get that on as tight as you can. And then we'll clamp the other side as well. You'll have a red and a black wire. It doesn't matter which is which. The colors are just from the plastic on the outside. Inside they're made out of copper, just like all the other wires. We'd like to measure resistance. The symbol for resistance is an ohm. So we see that this symbol right here has a V, ohm, and milliamp. So one of our leads is going to get connected into this port. Okay, now before we complete the circuit, we'd like to turn it on our desired setting. We know that this resistance is expected to be about 82 ohms. We know that from the color bands. So let's take our dial and put it on the appropriate setting. We want to be down in the ohm region. And we want it to go to a maximum of about 200. So let's just click that over to 200. We see that it's turned on. It's not giving us a reading yet because we're not connected yet. So let's plug it in and let's see what it tells us. So this tells us that the specific resistance of this resistor is 81.8, and the uncertainty of a digital multimeter in general is a 1 in the last digit you can read. So in this case, the reading would be 81.8 plus or minus 0.1 ohms. Okay, so that'll be the first thing you do using your multimeter, is measure each of the 4 resistances. Then the next thing we'll do in the experiment is we'll take resistors R1, R2, connect them in series, and use the multimeter to read the series equivalent resistance. So to connect them in series, it just means connect them in a row. I'm going to use that with an alligator clip. Okay, so that's held there rather firmly. I'm going to connect one lead to one end, one lead to the other end. So now these are in series because they're connected right in a row. We go from one resistor straight into the second one. What we expect about resistors in series is that they will have the same current. Okay, that's something we know about series. I'll connect it, I'll look at my resistance reading. I see that it's 171.5. The uncertainty will be plus or minus 0.01. You'll do a theoretical calculation, and we expect that the series equivalent resistance that we're reading here, it should be the sum of these two resistances. That's explained in the theory video. Okay, so that's how you'll use the multimeter to measure the series resistance. We'd also like to do the parallel resistance of resistors R3 and R4. I'm going to take my resistor R1 and R2. I'll just put those away. I'll pick up R3 and R4. For R3 and R4, we want those connected in parallel. That means top to top and bottom to bottom. So to connect these top to top, it's a little fiddly. This will be a nice one to have a partner to work with. I'll just cross over the two ends here. I'll try and catch those with this alligator clip. Okay. Now I'll do likewise here on the other side. I'll bend those a little bit so they cross over. Clip that on. Okay, I think I've got those connected pretty well in parallel now. So top to top, bottom to bottom. Then I want to look at my multimeter and see what my reading is, 52.3 ohms. So that's giving me the equivalent parallel resistance. Like you'll see in the theory video or in the instruction file, when we want to calculate the equivalent resistance, we have to add the reciprocals. So 1 over R equivalent will be 1 over R3 plus 1 over R4, and then we'll calculate the equivalent resistance that way. Okay, so that's using the multimeter and all of our apparatus.